In this video, I'll walk you through practice question that we have for matching chart question, and those are actual questions from BMAT exam. So before we do that, let's do a really quick review of techniques we use to deal with this type of question. So this will be a review, so if you haven't watched my previous video on the techniques before, you should do so. Okay, so the three techniques we use. First, large portion. When we have to match data to graph, oftentimes if you look at the small portion, like 1%, 2% of the total, it will be difficult to tell the difference. That's why we often focus on large portion. Distinct feature, well, if you have a graph with, for example, a pie chart with something of equal portion, or you have one category which is 1/2 or 1/3 of the total, that will be easier to spot by the eye. Okay, distinct feature. And finally, relative. If your graph is not labeled, if your graph comes without a scale, it will be difficult to tell the exact amount, like 45 meter, 25 grams. That will be difficult. But if you instead look at the relative size and order, it will be easier. Again, if you listen to this and feel like, hey, I don't know what you're talking about, I encourage you to go back to my previous video and watch it. Now, let's take a look at the first example on this category. I encourage you to pause the video and read the question by yourself. So, the table below summarizes GCSE result for 5 schools in town. If you are given a table like this, when you read the question, you don't need to go into every single detail. You just need to get the big picture of what kind of data is presented in the table. In this case, the table gives you data on each school in different measures: number of students taking GCSE, percent achieving 5 or more, number of students with special educational need, and absenteeism rate. Now, the question asks, a graph has been drawn which summarizes this data, but the graph has not yet been scaled or labeled. Okay, if you look at the graph, there's no label. We have the x-axis. However, we don't know what x and y is. We do not know whether or not x is number of students or something else from the table. And also, the graph has not yet been scaled. So we have the dots, but we do not know the amount. And the question asks, which of the following could be shown on each axis? Okay, and they give us choice. For example, choice A proposed that the x-axis represent absenteeism rate, and y-axis here represent percentage achieving 5 or more. Okay, now since the graph is not scaled, the only way we can work around this is to look at relative order. Okay, so if you look at the technique we talked about earlier, it will be this one, relative size or order. Here is how it works. You see this dot, let me highlight it in blue. If you look at the order or the ranking, it is ranked the highest in X, right? Because it is the far right. But however, for the same point, which is the same school, if you look at the Y here, this school is the highest in Y, second highest, third highest. So the blue school, I don't know which one it is yet, but it is ranked the 4th in Y. And we will be using this information to rule out or eliminate the incorrect answer. So let's take a look at choice A. A proposes that x-axis is absenteeism rate, y-axis is percentage achieving 5 or more. Which means, according to A, if you look at the blue school here, it is highest in X but ranked number 4 in Y. Which means this school should be the highest in absenteeism rate but ranked number 4 in percentage achieving 5 or more. Let's check that. Okay, first, according to A, which school is ranked the highest in absenteeism rate? You go to your table. This is absenteeism rate. Look at the highest. That will be this one, 9.1, and the school name is Castle. So according to the data we have, if A is correct, the one ranked highest in absenteeism rate need to be ranked number 4 in the y-axis, which is percent achieving 5. So Castle, let's take a look at percent achieving 5 or more. So Castle has 40. Is it ranked number 4? The answer is yes. Okay, 40 is number 4. So according to A and the blue point, choice A cannot be ruled out. We haven't found anything which is suspicious about A yet. However, we can repeat the same process to B, C, and D. So, according to B, X is number of pupils, Y is percentage achieving 5 or more. So, if B is correct, the highest in number of pupils that school need to be ranked number 4 if we look at percentage achieving 5 or more. Number of pupils is here, number taking GCSE. Which school is the highest? The answer is this, Castleford. Okay, this is the highest in X. This school need to be ranked number 4 if we look at the Y, which is percentage achieving 5 or more. So here, 56. Is it ranked number 4? The answer is no. If you look at percentage achieving 5 or more, Castleford is ranked number 3, not 4. At least we know B is not correct. Cross it out. Repeat the same process with C. Again, number of pupils and absenteeism rate. Number of pupils, which school is the highest? The same, Castleford. Now look at absenteeism rate. Is Castleford ranked number 4? So here, 8.3 is in fact ranked number 3. Again, not number 4. C is wrong. Choice D, x-axis number with special educational needs, y-axis absenteeism rate. Again, ranked highest in X. This is number of student with special need. Which one is the highest? Castleford again. Now we need to check, is Castleford ranked number 4 in absenteeism rate? No, it's not. Okay, it's ranked number 3. We already checked. D is crossed out, is inconsistent. We go with choice A. Okay, just to recap for the first example, we do not have a scale. The graph is not yet being scaled. That is why it doesn't matter the actual number 56, 18, 40. Of course, we can try to read from the graph. For example, maybe this is only like 75% of that. You can do that, but it's difficult. In this case, if you don't have that data, let's take a look at rank or order, because you can get that from the graph easily. Next question is a little different, but let's try it. So this is from 2009, question 3. Again, if you need to pause and read the question, please do so. Let's read it together. I recently asked 4 members of my class to draw bar charts from some data that we collected. Every student managed to produce a chart, but they all drew it exactly 2 bars at the wrong height on the graph. This sounds like something important. I'll highlight it. So everyone draw it wrong at exactly 2 bars. Okay. I drew the correct bar chart from the graph. Unfortunately, I didn't label any of the charts, so I now do not know which one is correct. So right away, you know that there's one correct and the rest are wrong, in a way that if you compare the correct and the wrong, the difference is at exactly 2 bars. The question asks, which graph correctly represents the data that we collected? In other words, which graph is the correct one? Okay, so what is the situation here? Out of the 5 choices, only one is correct. And if you compare the correct and the wrong, they said the difference is exactly 2 bars. Now, we'll use that to eliminate some choices. But before we do that, we need to agree on the rule that we'll be using. In this case, if I randomly select 2 graphs, for example, A and B, if I compare them, if I found out that the difference is 3 bars, how can we interpret the result? Something is not right, right? They said that if you take the correct one and compare to the wrong one, the difference should be exactly 2 bars. So if you compare them and the result, the difference is not exactly 2 bars, it means you are comparing the wrong one and the wrong one. Okay, because if one of them is right, you're supposed to get the difference of 2 bars. Okay, so if you get anything other than 2 in terms of the difference, it means both of them are wrong. Let me write it down. Compare 2 charts. If the difference is not 2. If the difference is not 2, it is impossible that you are comparing the right one to the wrong one, which means both of them need to be the wrong one. So both charts are wrong. Okay. Let me repeat the rule again. Compare 2 charts. If the difference is not 2, we know right away both of them are wrong. However, if the difference is exactly 2, can we be sure that one of them is right, one of them is wrong? The answer is no. You can be comparing 2 wrong ones, and it is a coincidence that they are the same. Right? They differ by 2, right? So if you compare and you get the difference of 2, it doesn't mean anything. You cannot rule anything out. But whenever you compare and you get the difference of 1, of 3, of 4, or 5, both of them can be ruled out. So in this case, we can randomly selecting any pair and do a comparison. Keep doing until you can eliminate all but 1. Right? But for this question, we are going to be a little smarter. Okay, we try to speed up the process because we are competing against time here. We know that if we can pick 2 completely different graphs, the difference will be higher than 2, and we can rule them out. Okay, so eyeball it, try to pick 2 graphs that look very different. In this case, I'll do A and C. They look A and E. They look really different. You look at A, okay? The first bar, A and E. Are they different? Yes. Difference number 1. This bar, again, difference number 2. This bar, compare A to E, difference number 3. We have 3 difference, so we said, oh, actually A and E, they are both wrong. Because the difference is not exactly 2. What else can we do? We can pick a new pair. I'll do B and C because they're next to each other. Bar number 1, same. Number 2, difference number 1. Okay. And then difference number 2. Same. Same. Okay. So we already compare these. The difference is exactly 2. That's why we cannot do anything. C and D, do the same. I'll go a little bit faster now. Okay. So C and D, same. Same. Difference number 1. Same. Difference number 2. Okay. Cannot do anything. What else? We can compare B and D. Same. Difference 1. Same. Difference 2. Same. And difference 2. Okay. Again, we already do the comparison, but we cannot rule it out. Now, are we done? Do we hit a dead end? Not really. Because we have A and E. They are wrong. We know they are wrong. They cannot be the answer, but we can use them to compare to the rest of the choice. And again, I'll take E and compare with everything else because I feel like if you look at the similarity and differences, E is more like out of place. It differs from everyone else. So I'll use E and compare that to B. Okay. First, difference number 1. Difference number 2. Same. Difference number 3. Okay. So 3 difference at least. This is wrong. And E, let's compare it with C. Difference 1. Same. Difference 2. Difference. Difference. So we have 4 difference. And we know that E is wrong, C must be wrong. And finally, we are left with only one possible right answer, which is D. Okay. So let me recap. This question, we do not have the right data. If we do, it will be really easy. Okay, so we need to use a relative approach. So we compare among the choices and try to rule out the one which does not make sense. Again, in this kind of question, we do use a lot of relative approach, order, size, or comparison. Finally, last question I have for you on this category, question 3 from 2010 exam. So the pupils in a class took 2 tests. The result on the teacher scatter graph are shown below. So you have the name of each student. You have the score of each test. The question asks, whose results are shown by the white diamond? Here, the white diamond. Now, this question, they give us label for each axis. We know that the x-axis will be test 1, y-axis will be test 2. But we do not know the scale. Again, if we do not know the scale, we use the relative approach. We look at the ranking or order. If you look at it in terms of test number 1, this guy, he has the highest score. This guy is ranked number 2 in terms of test 1. 3, 4, and the white diamond is ranked number 5. 5th on test 1. And that is easy because we know all the data. We look at test 1. Who has the highest score? Well, ranked 1. Rank 2 is here. Rank 4 is... rank 3 is here. And rank 4 is here. And then rank number 5 will be Aaron, 63. And the answer is C, Aaron. Again, from this question, this is not a difficult question. You can look at the X and count it. Rank number 5, you get to the answer. You can also use the data from the y-axis, which is test number 2. Okay, highest, number 2, number 3, number 4, number 5, and you read test 2 instead. Okay. Now, we have looked at 3 sample questions from the actual BMAT exam, and you see that the technique we use a lot is relative. We do not have the scale, we cannot read the exact number, but ranking and order is really useful.